Intro. NASA citizen scientists have recently discovered an object speeding through space at around 1 million miles per hour, known as Quasar J1249. This faint and fast-moving body may be a low-mass star or brown dwarf, pushing the boundaries between a star and a gas giant. What's truly intriguing is how this object was expelled from the Milky Way. It may have been ejected by a supernova or black hole interaction. In the discovery and what we know about Quasar J1249, this video will dive into this exciting discovery, explore the science behind it, and discuss why it matters. So, without further ado, let's get started. Using data from NASA's Wide Field Infrared Explorer WISE mission, which has been instrumental in mapping the sky in infrared light, citizen scientists Martin Kutnick, Thomas Blee, and Dan Seelan were able to detect this hypervelocity object moving at breakneck speeds. Initially, the object appeared as a faint blur across the screen, but upon closer examination and follow-up observations using ground-based telescopes, it became clear that this object was unlike any other previously discovered. It stands out because of its relatively low mass. While it is difficult to classify the object definitively, scientists speculate that it might be either a low-mass star or a brown dwarf, a so-called failed star that did not accumulate enough mass to trigger hydrogen fusion in its core. Brown dwarfs, although common, typically do not travel at such extraordinary velocities. In fact, while citizen scientists involved in the Backyard Worlds Planet 9 project have discovered over 4,000 brown dwarfs, none of them have been observed exiting the Milky Way at such a high speed. The unusual speed and trajectory of this object specifically suggest that it was ejected from a larger system through some form of explosive event, likely a supernova or a close encounter with a binary black hole system. Observations of its chemical composition further indicate that this object might be ancient, originating from one of the first generations of stars in the Milky Way, which is truly fascinating. The excitement surrounding this discovery is noticeable among the citizen scientists involved. Kotnik from Nuremberg, Germany, described his disbelief when he first saw how fast the object was moving, convinced that it must have been reported already. However, this discovery was entirely novel, adding to the mystery of hypervelocity objects and opening new opportunities for exploration and study. The science behind Quasar J1249's journey. Hypervelocity objects are typically stars or remnants of stars that are traveling at such high speeds that they are on the verge of escaping the gravitational pull of their galaxy. These objects were first discovered in the early 2000s and are often linked to interactions with supermassive black holes, such as Sagittarius A*, the black hole at the center of the Milky Way. However, Quasar J1249 is unique in that it is a low-mass object, unlike the massive O and B-type stars that were initially found as hypervelocity stars. There are several hypotheses as to how this object gained such velocity. One possibility is that it was part of a binary system in which one of the stars was a white dwarf. As the white dwarf accumulated mass from its companion, it eventually exploded in a Type Ia supernova, launching the companion Quasar into space at an incredible speed. This scenario is supported by the fact that this object has a low metal content, suggesting that it is an older star formed in a metal-poor environment. Another potential explanation involves interactions with black holes. If this object originated in a globular cluster, it could have been ejected due to the gravitational interactions within a system of black holes. Such interactions are rare but have been simulated and shown to be capable of imparting the necessary velocity to propel a star out of the cluster and eventually out of the galaxy. This object offers a unique chance to study the chemical and physical properties of low-mass stars and brown dwarfs, which are usually too faint and cool to observe in detail unless they are nearby. However, with this velocity, scientists can gather valuable data that would otherwise be out of reach. This opens new doors for research into the formation and evolution of brown dwarfs and other low-mass stars, especially those from distant ancient parts of the Milky Way. The implications for astrophysics and future discoveries. Quasar isn't the only hypervelocity object. There have been others discovered in past years. For example, a brown dwarf named YSE also exhibited similar high-speed movement, although not as dramatically as Quasar. Ancient stars within globular clusters have too been observed to experience similar ejection processes due to gravitational interactions with black holes or supernovae. In addition to brown dwarfs, several hypervelocity stars have been observed. For instance, in 2010, a star that's name starts with H was found traveling at an astonishing 1.6 million miles per hour and is thought to have been ejected from the center of the Milky Way. Similarly, two stars named Lamoste, discovered by Chinese astronomers, are also unbound hypervelocity stars, demonstrating the variety of objects experiencing such extreme velocities. But this raises a question. Is it possible that any of these hypervelocity objects could collide with Earth? The answer is that it's highly unlikely. Objects moving at such high speeds, like hypervelocity stars or brown dwarfs, are typically on trajectories that take them out of the Milky Way or through vast empty regions of space. Nevertheless, studying their movements allows scientists to refine models of stellar behavior and galactic dynamics. Finally, the role of citizen science in this discovery cannot be overstated. Projects like Backyard Worlds, Planet 9 illustrate how, with the right tools and guidance, amateur astronomers can contribute to groundbreaking discoveries. The identification of quays resulted from years of dedication by volunteers. This collaboration between professionals and citizen scientists will likely continue to yield exciting breakthroughs in the future, expanding our knowledge of the universe by broadening the scope of research into ancient stars and brown dwarfs. Discoveries like this one provide vital opportunities for learning more about the history and evolution of our galaxy. The discovery of hypervelocity objects like quays J1249 opens up intriguing avenues for further research in astrophysics. These phenomena not only challenge our understanding of stellar evolution but also offer insight into the dynamics of our galaxy. The interaction between massive celestial bodies, particularly in densely populated regions like globular clusters, can lead to dramatic outcomes, including the ejection of stars and brown dwarfs at astonishing speeds. Researchers are particularly interested in how these hypervelocity objects can inform theories about dark matter and the overall structure of the Milky Way. The pathways these objects take through space can shed light on the gravitational influences exerted by unseen matter. Additionally, studying their chemical signatures provides clues about the environments in which they formed, potentially revealing information about the early universe. With advancements in observational technologies, astronomers are now equipped to detect even fainter and more distant objects. Upcoming space missions and ground-based telescopes promise to enhance our ability to monitor the cosmos. The collaborative efforts of professional astronomers and citizen scientists will remain crucial in uncovering the mysteries of these fast-moving entities and their implications for our understanding of galactic history and evolution. Thank you so much for watching. We hope you enjoyed learning about the exciting discovery of quays and the fascinating world of hypervelocity stars and brown dwarfs. If you found this video informative, be sure to like, subscribe, and hit the notification bell so you don't miss any future updates on the latest space discoveries. Let us know in the comments what you think about these incredible objects and what other cosmic phenomena you'd like us to explore next. Until then, keep looking up and stay curious.